back to YouTube channel. Naren here. Today we will discuss section 1.5 functions, modeling and proportionality. Before we start, I request everyone to like and subscribe my channel Naren underscore here. Okay, thank you for your support. Now let's start, and we will start from definition. A quantity y is directly proportional to a quantity x. So we have two quantities, quantity x and quantity y. The quantity y is directly proportional to a quantity x if y, it can be written as in this fashion, this relation, y equals to k times x for some constant, for some non-zero constant k, constant which is non-zero. So if we generalize this, if q is directly proportional to r, we can always write k times r mathematically. So what does this imply? This implies that q is directly proportional to r, and you may see this relation in physics. This is proportionality relation, this relation. For example, force is directly proportional to product of masses, so this type of relation. But when this proportionality relation is removed and written in terms of equation, they choose to write some constant and write this in this fashion. So please take care of that. Now I have one remark here. So remark, if you look at this relation y equal to k times x, if you double or half the value of k, if you double or half the value of k, or any other things, you multiply, you make it 3 or make it 1 by 3, or whatever you do, you double or halves the value of, it depends the value, it also changes the value of y. So doubling k will double y value, having k will have the y value. So that's the remark. Now let's discuss problem number 1. So which of the following functions represent a direct proportionality? Proportionality. So number A. Let's discuss a few of the examples. Say we have some function f of x equals 19x. So does this represents, you have some quantity on the left hand side, some quantity on the right hand side. So this is function. Does this represent a function? So first, the basic idea. So since this is a basic problem, you may not see its significance, but it is very useful idea. You always compare with the standard form. What is the standard form in this case? K times the input, right? In this case, input is x. If you compare, can we write this right hand side in this form? Yes, it is. We can write it where k is 19. So what does this mean? Yes, f of x is directly proportional to x, where this k is called constant of proportionality. I forgot to mention here, this constant k is called constant of proportionality. So this is constant of proportionality. With here, if we come back to problem, k equals to 19, In this case, constant of proportionality is 19. Similarly, let's do another problem. Say we have another function which is input t equals t over 53. So is this a does this represent a direct proportionality relation? Yes, it does, and this is k times t, where k equals 1 over 53, right? Make sense? Yes, it does. And constant of proportionality in this case is 1 over 53. So this also represents a direct proportionality relation. Number third is a of n, say, equals pi square n. Does this represent a constant proportionality? So can we write in this form? Yes, we can. And what is k here? It is pi square, and pi square is a constant, 3.14, right? So yes, this is also a direct proportional relation. What is number D? Number D. So these until now ABC are the examples. Let's see one of non-examples. Let's see, we have 2t plus 5. Can we write somehow in this relation only? There is no possible way we can write it in this fashion, because there is always this plus 5. So this is not equal to k times t. Hence, it is not a direct proportionality relation. It does not represent a direct proportionality relation. So, is this making sense? I hope so. Let's discuss another problem. I have another problem. Problem number 2. Please pause the video and go through problem number 2, and then once you resume it, I will directly discuss the solution. I hope you went through the problem. Now let's solve the problem number 2. What is the relation between y and x? First of all, we write um, the relation that is written in terms of sentence in words in English. We first write it in mathematical terms. So the relation says y varies directly as the cube of x. So y varies directly as a cube of x, but to maintain this relation we need some constant for some non-zero constant k, right? This is how we write mathematical relation. So this is number A. What is the relation? This is the relation between y and x. But this is not a complete relation because we don't know what k is. So first we will find k, and that will give us a complete relation between x and y. What else are we given? We are given y equals to 20 when x equals to 2. So use these values in our relation. So this implies 20 equals k times 2q. Can we solve it for k? Yes, we can. So this is 20 equals 8k, and if we divide both sides by 8, we get k equals 20 over 8. Now use this k value here, and we will get y equals to 20 over 8 x cube. So this is the relation. You can convert this fraction to the lowest term, but no need. If you want, this is 4 times 5 and 4 times 2, which is 5 over 2. It's okay to, it's your choice if you want to use it or not. So this is relation between y and x. Next, number B. What is number B? What is y when x is 4? So what is y when x is 4? When x is 4, y can be written as, can be found from this relation. What is this? Right? So 20 over a, this is 4 times 4 times 4. So 4 times 2, right? And 2 times one of the two. So this is 20 times 8. So this is 160. So this is how we find y. So first we found the relation between y and x, and then we plug the value of x and we found y. There is one more problem. Again, pause the video and go through the instructions. Okay, I hope you went through the instructions. Now let's try to solve the problem. So revenue is directly proportional to number of bicycles sold. So let's say revenue is denoted by R and number of bicycles is denoted by N. So what does this mean? This means revenue is directly proportional to number of bicycles sold. But to write it in mathematically, we use is equal to sign and multiply the quantity by k, right? So what is k? For some non-zero constant k, right? Now what is next given? The next is when 50 bicycles are sold. So what is 50? 50 is number value of n. The revenue is 20. So R is $20,000 in this case, $20,000. So this is also given. Now these are the given things. What is the constant of proportionality? So they are asking the constant of proportionality. So they are asking the value of k. So just plug these values over this relation and find the value of k, or constant of proportionality. K times 50. Divide both sides by 50 will give you k equals to 400. And what are its unit? How do you find the unit? So to find unit, so original relation is k. This, when you divide both sides by n, you will get k, right? So k is r over n. So whatever the units, right, the respective units, revenue is dollar, right? Dollar, and the number is bicycle. So dollar per bicycle is the unit. Similarly, number 2, it represents what is the revenue if 75 are sold. So what is r equals to what? R equals to what when n equals to 75? So first of all, write the relation the same way we did it here. So once you find the value of r, what is the relation between r and n? So relation is, what is the value of k? K is 400. This is times n. So this is relation. So we are given n. So what are we given? 75. So this will give us our final answer, and which turns out to be, we can multiply it, and which turns out to be $30,000. $30,000. So this is how we solve the problem. So these were some application problems of direct proportionality. Similarly, we have another relation. I just want to discuss it briefly. I will not go in depth because we have another whole section coming on this. Inverse proportionality. So similarly, when two quantities are inversely proportional, we write, so say inversely proportional is, in physics they are written in this fashion. But in mathematics, this relation is written y equals to k over x. This represents inverse proportionality. What does this mean is, if you increase x, y is decreasing. When you decrease x, y is increasing. So it's that just the opposite type of relation. That's why we call it inverse proportionality or inversely proportional. We will discuss this in another section. Okay, we will stop for now. Thank you for watching. Please do not forget to like and subscribe my channel, and also please show your support by liking this video and asking questions in the comment section. Thank you.